Hey, Year 11s, thanks for coming, guys. Okay, so I'm going to get straight on with today's lesson. Share screen. Let's crack on. Right. So today is actually organics lesson 6. I've mislabeled it on YouTube, labeled as number 4, but it doesn't really matter. So on lesson 6, and we're moving on to the next family, which is alcohol. So 3 learning objectives, guys, all nice and easy, partly because I'm assuming that all of you guys can do the first one. Yeah, so the first one is to be able to name alcohols and also to recognize the functional group. So I'll add that on really, and you can actually add that on as well. Oh, thank you very much. I have frozen the screen for you guys. There you go. Thank you. Unfreeze. There we go. So name alcohols. It's also nice to say, I'll reduce that pen size. Yeah, to recognize the functional, Toby, recognize the functional group. Next one is, so naming them, we need to be able to name, we all know that we have to be able to name up to 10 carbons. And then it's nice that at GCSE, no numbers are required. So you just get methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, heptanol, all that jazz. But we now recognize that there are these isomers where you can move the alcohol group. You do not need it at GCSE, but it's nice to be able to go that far with you guys. So naming alcohols. The next one is we then pick up a very specific alcohol, and of course it's the one that everyone loves. It's our Friday night alcohol, which is ethanol. So I need to teach you how to make it, which is fun. So we need to know how ethanol is made, and then also give its uses. Now that last learning objective is, I never used to teach that. When I first started teaching, I didn't include the 3rd learning objective. And I didn't because it was just kind of like an assumption that everyone knows. And then I realized that the one that everyone puts is wrong. Ashley, what is the major use of ethanol? It's a what? Sanitation. I like it. It's a great answer. Well done. Can be used as a sanitizer. Absolutely. Yeah, the one you're not allowed to write down is you drink it. Please don't. Yeah, this is not a correct use. Now, often people argue with me about this. And they're like, well, hang on a minute, everyone drinks alcohol. And I'm like, sure, but telling everyone in the exam, it gets you drunk is not a good thing to write down in a GCSE exam. Yeah, so the other reason is because less than 1% of all the alcohol we make is drank. Yeah, we actually drink very, 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 very little of it. The major use is a fuel. Is what we use it for. So, okay, so first of all, let's do a bit of nomenclature. It's always nice to remind you of that really stupid word. So, you can just put this down, nomenclature. It's nice then to also remind you of IUPAC. These are the old guys who came up with the naming system. Yeah, so if it says, give the IUPAC name of, you don't freak out about IUPAC, it's just, what did the old guys call it? Yeah. So let's draw the first one, and I think I'm going to go, I'm just going to work across the room. So Anna, name me this guy, please. The one that everyone, of course, loves. I like it. Now, can I just point out, it's nice for me to just remind you guys of the naming process, because she gave me the name instantaneously, which is great. So the first thing she said was eth. Yeah, and eth, of course, is the 2 carbons. Yeah, the next thing she said is an. And that's important. It's amazing how many times with my students is they forget this. The an is telling you that it's a carbon-carbon single bond. And then our final part of the structure is this section here. And there's our functional group. So it's nice to color code the molecule and show how it's being named. So this is ethanol. Yep, this is our Friday night alcohol. This is the one that everyone drinks. Can I just point out, by the way, yeah, you can drink any alcohol, but they will also kill you along with getting you drunk. They will all get you drunk, but they're all, and by the way, this is true. This is a true statement. All alcohols are poisonous. Yeah? So, and everyone here knows that you can die from alcohol poisoning. If you drink too much, it will kill you. The fact that the other alcohols will do it quicker than ethanol will, yeah, it doesn't take away the fact that they are still poisonous. So just it's nice to understand that. But and this is where we get to add in our the extension to our first learning objective, which is this bit. So you can circle this and just label this as the functional group. And the functional group is I'll put underneath it, the part of a molecule that provides chemical properties. There we go. It's the only, and it's funny because it's the only bit we really care about. Yeah, you look at these molecules and what you're actually looking for is there a functional group? We don't care how long it is. We don't care how many branches it's got. What we're looking for is there a structure that tells us its properties? Yeah, let's do another alcohol at this point. I'll leave that there just for a second. And then I'm going to go to Shan. No, I'm going to go to Moses, since you're next to Anna. Moses, can you name this one, please? Say again? I like it. Well done. Could you give... Now, that's totally acceptable at GCSE, Moses. I'm really happy with your answer. Thank you very much. Yeah, so at GCSE, this is prop for 3. It's nice to color code this again. Yeah, I'm going to rewrite that again. So we've got prop, and prop stands for 3. And then he said an, which is great, because the an tells me it's all single bonds. And then, of course, he added on our functional group of the ol. That there is GCSE through and through. Thank you very much. I'm going to go for Con. Can you give me the A-level name, please? Well done. Good man. Really, really pleased. At A-level, this is Propan1. Oh, nice to remind you to separate letters and numbers, you use a dash. To separate numbers, you use a comma. To separate letters, you don't. Movers. They wouldn't, at GCSE, they wouldn't care. At A-level, they would. But at GCSE, it will just say in the mark scheme, ignore any numbers. Yeah, cool. I don't know why you'd add in a two on that one, but... with the number, I totally get it. If you're not confident with the numbers, just don't include them. GCSE genuinely doesn't require them, but it's nice to get the good practice in. So we've got propanol. Oh, now we get to do a really nice thing. Gonna go for, Ruby's asked me a question. Gonna go to Shan. Shan, impress me. Which of those 2 alcohols will have the higher boiling point? Well, so, did you say propanol? Well done. It's a really common thing for that. I'm just focusing on so that and still there. So propanol. Can you now tell me why, Shan? No, lost it. Done. Vic. 1 mark. Stop. You're doing great. So we can now put a little note of Bene over here. Add this to your notes. Propanol has a higher boiling point, BPT, compared to ethanol. Now they're going to ask you to explain why. This is GCSE level 8-9. Yeah, they're going to ask you to explain. The first mark Vic has just got, which is fab. Propanol is a larger molecule. 1 mark, Vic. Give me the next one, please. So, ... She's about to lose it. Go on. What does that then change? Okay, Vic, I'm gonna ask you to now, okay, Shan, gonna go back to you for a second. Can you tell me, so propanol has a low boiling point. 5 marks. Run Susan Boyle, please. Why? What's its structure? Well done. The structure is simple covalent. Bonds, please. Low boiling point. It's only 1 time you ever use this. There's no layers. Between the what? Between the what? Molecules, thank you. We've got wimps between the molecules. Strength, Toby. Weak number. Wimps. Few. Energy low. Guys, that was a disaster. Well done for that. That was excellent. Let's run that, shall we? But we'll come back to that in 1 second. So if you have a larger molecule, what happens to my wimps, please, Nick? What am I doing? What am I doing here? Am I teaching chemistry? Have I taught you guys any chemistry? Isabel, can you please fix this, please? Propanol is a larger molecule. So I lost it, missed one. I'm happy to do the energy at the end. Simple covalent. So propanol is a larger molecule. So you can't say that. You can't. You're not breaking the bonds. Go on, Con. They'll actually give you that. I don't mind that, larger. Yeah, so stronger. And by the way, that's the important bit. Notice my change in color. Stronger wimps. Stronger, weak intermolecular forces. You know, you can't write down wimps in your GCSE, but it's easier to remember that way. Yeah, so stronger wimps, so more energy. So more energy needed to boil. That was a disaster. It's not your fault. Bonding is the most important and probably the toughest topic in chemistry, period. And the problem is we haven't done it in a long time. And so it's really important that I go back over bonding with you guys. Just remember that everything else is giant. Giant ionic lattice held together by the electrostatic attraction between oppositely charged ions. These attractions are very strong. There are millions of them, lots of energy. Giant covalent. We have only covalent bonds. Covalent bonds are very strong. There are millions to break, lots of energy. Metallic. You have, it is a giant metallic lattice of cations surrounded by a sea of delocalized electrons. The electrostatic attraction between the cations and the delocalized electrons is very strong. Therefore, there are millions of them, loads of energy. You're done. They're all giants except for the simples. And the simples, you're just talking about wimps. Yeah? So nice to do, by the way, that's actually really important to do this comparison of sizes. That there is a grade as a level 8-9 question. Isabel?
It's the simple covalent bonds.
No. Yes, simple covalent bonds. Because this is the picture. The only image, so here's ethanol. Yeah, here's ethanol. So you are not breaking the to break a covalent bond takes 2000 degrees Celsius. I'm not breaking those bonds. What I'm breaking is the wimps between the molecules. We know that between these molecules, we have these little dashy lines, which we call weak intermolecular forces. And what we're doing is we're breaking them. We are not breaking bonds. Yes, these are intramolecular bonds, and they're covalent. Not breaking those. Yeah, but we have weak intermoleculars between the molecules, and those we break. In graphite, yes, there are wimps between the layers in graphite. Graphite has her very own set of stories. She's a nightmare. Ashley, never, ever, like. The only time you do is when you do enthalpy and they'll break bonds in that. But yeah. But otherwise, we don't like to break them. It's thousands of degrees. These bonds are the strongest bonds I have are covalent. Yeah, we're not going to break those. We're going to break the wimps, not the covalents. Okay, so we've got propanol. Let's go for another one. I'm going to make this a bit harder now. I'm going to go for Kieran. Kieran, I'm going to make this real A-level for you. Can you please name me this one, please? Impress me. Impress me, young man. Impress my YouTube channel. Outstanding. I am so very, very impressed. This is two. He even did that without writing anything down. That's annoying. My A-level kids can't do it that well. That's upsetting. 2,2 dimethyl. Let me show you where that comes from. Carbon, 1, 2, 3. He has just named me this one. I have 2 branches of methyls attached to the 3-carbon chain. Let's change my color. Now it's propan, and it's prop. I'm going to make my pen a bit thicker there. Prop, because there's 3 carbons. Then, of course, it's an an because of these single bonds. Propan, and then he even gave me the correct number as well, which was outstanding for this being attached on at the 1 carbon. There's the A-level answer. You'll never get that at GCSE, by the way, so don't worry, but you are expected to be able to draw it at GCSE. Yeah, what they'll give you this, and then they will say, draw an isomer, and you just straighten it out. Put all the carbons in one row. Yeah, pentan 1-ol, you're done. Yeah, just straighten it out. Move the carbons around, all that jazz. Cool. By the way, Kieran, very impressed. Well done. Really impressed. That's working at an A-level standard, that. Really good. Not only that, a really good AS. It's an AS standard. It's a really solid AS standard. The speed at which you built that and in your head without writing anything down, very impressed. Yeah, really am. Okay. And once again, functional groups, always the same, recognizing this OH thing. Can I now I'm going to now go to the internet and show you some garbage internet. So the internet, I don't want that. I just want that one there. There we go. So just to quickly show you on the internet, if I Google ethanol, now don't get me wrong, like the internet is a great resource, but it doesn't half have some garbage chemistry on it. Just to say that right there, that there is a nightmare for me, because guys, this is a habit of the internet which drives me crackers. Because on that picture there, they have got rid of the most important bond in the whole molecule. Do not do this. This is not allowed. Please don't do that. Yeah, this bond here is the most important bond in the entire molecule. And the internet very, very often just makes it hello? Delivery? Casa Tropicana? Block C? Yeah. That's correct. I can come down and collect it if you like. Okay, I'll. Okay, you can. 1 o'clock. Okay, I'll see you then. Bye. Oh, I know I'm on YouTube. I'm absolutely aware that I'm on YouTube. Anyway, the next thing I need to just mention here. So number 1 is this bond. So if I just do this, carbon, let's try that again. This is what I wanted just to remind you. This here, yeah, is correct. Yeah, but just please do not do this. That is not okay. So A, don't do that. There's another one which this is now very specific for Edexcel. So you guys are going to see ethanol appear in several questions, and what you're actually going to see is this C2H5OH. Makes me shake. It's horrible. It's disgusting. Edexcel, what they've done here is they've blended 2 types of formulae. Literally makes me feel queasy. That there at A level is never correct. Ever. Don't ever write that down. But I have to teach it to you because that's how you're going to see it in your exam. And I'm sorry for that because I actually emailed them one time and said, can you stop doing this, please? It's bad chemistry. And they just sent me an email just saying, no. So I was like, okay. So this is what you're going to see for ethanol in your exam. The correct one, by the way. So what they've done, so there's 2, we know that in organics, there's loads of types of formulae. The first one you pick up is C2H6O. And I can ask Isabel, what type of formula is this? No, it's definitely not. Oh, that's okay. I'll allow you to have empirical because it is the same as the empirical. I'll give you that. But sure, so it is the empirical, but it's more than that. Well done. This is the molecular formula. This is the actual number of atoms of each element in the compound. Yeah. Then we pick up empirical. In this case, it's the same because the oxygen's already at 1. But then we pick up this guy. This is structural. Yeah. That there is the structural formula. Now, you guys don't deal with this at GCSE. They deem it too hard. It is the hardest one to get used to. Yeah. So structural. And then you have displayed. This one you do deal with at GCSE. Yeah. The displayed is showing all bonds. Do you now realize that the definition is show all bonds? So if you make the OH bond vanish, you lose it. That's why the internet's terrible for this. Because I've just got students every year who are losing that mark because they just do that. So just be careful. Just be aware of it. So this is displayed, showing all bonds. Yeah, displayed formula. And what Edexcel have done is they have blended structural and molecular here. They've given you the start in a molecular and then tacked on an OH at the end. It's disgusting. It's just, ugh. Sort it out, Edexcel. Just get it right, will you? It's bad chemistry in every way. But what I'm going to tell you is you are going to see it like that. So you just have to accept it. I have to. I mean, every time I spit on the paper every time I see it. I just have to do that. Just to let you know, with when you get to A-level, guys, the displayed is what you latch onto at the beginning, and then you learn to translate that into structural, just so you know. It's not as bad as it looks. You're reading it from left to right. CH3, CH2, OH. It's not as bad as it looks. Just to show you another one, if I give you this as I'll give you one from GCSE. There you go. So if you were going to translate this into structural, guess how it starts? Ben, how do you think that structural is going to start? Okay, fine, naming it, fine. It's all right, you finish the name if you like. Hang on, let me color code this for you. ETH, yes, where's the next bit? No, always go for this bit first. And, thank you very much. Ethan, and then what's this? Don't worry if you can't remember. You've gone mad, gone crazy. What family is it? It is a family you need at GCSE. It's been a while since I've done families with you, Ben. I'm not upset by it. It's a good start. When? Can't remember. Sham? Say it, nice enough. Carboxylic acid. So the name is oic acid. That's ethanoic acid, otherwise known as vinegar. Yeah, that's vinegar, that one. You get used to these families, guys. There's 10 families at AS, by the way. You learn 10 families. It's not as bad as thing. You've already got 5 of them from GCSE. Enes, anes, ols, oics, and esters, technically, at GCSE. Anyway, so I'm just letting you know that this is how you're probably going to see ethanol in your exam. You'll see both the displayed and that, but Edexcel. Right, so we can name alcohols, and we can certainly recognize the group. Now we need to talk about ethanol. Oh, ethanol. So, can you put a new title, please, of making ethanol? Okay. So, we love this stuff. And we've been making it for thousands of years. Rubes. Why do you use structural instead of displayed? I can tell you why, because in order to draw something out, you need lots more space. If they ask you to give the equation and they just give you one dotted line, you write it, you're not going to have the space to draw it. So you have to then convert it to structural. Well, why would you? Because the molecular doesn't tell you how it's built. It could be something else. If somebody gave me this, C2H6O, and they were like, what is it? I'd go, well, it could be ethanol, but it could also be dimethyl ether. Could be this. This all adds up for bonds. Remember, carbon makes 4 bonds. Oxygen makes 2 bonds. It could be that. And that, the formula of that is CH3OCH3. That's not the same as ethanol. That stuff will knock you out. That's an anesthetic. So molecular doesn't help me. Structural tells me how to build a molecule. Second. And it takes up less space. It tells me how to build it and also takes up less space. Yeah, that's all. Anyway, so making ethanol. Okay, guys, there's 2 methods. Method number 1 is fermentation. This is the one, of course, that we've been doing for thousands of years. Yeah. Fermentation. And the other one is called direct hydration. Direct hydration. Okay, so let's talk about fermentation, because guys, this is the easiest thing in the world. Because fermentation, and if you're interested, yeah, you guys, this is super easy. Go to YouTube and watch some videos on brewing alcohol, because that's what fermentation is. This is something we've been doing since like Egyptian times, probably even earlier, but we've certainly been doing it on a relatively large scale since then. Yeah, and what we're doing, so the title, let's look at fermentation first. Fermentation. So here's what we're going to do. Number one is we're going to get, so by the way, does anyone here know how to make their own alcohol? Of course you can. Oh, thank you. So straight off the bat, it's nice that Toby said, I need yeast. Well done. So I'm assuming you picked this up from biology. Yeah, we're gonna need yeast. Yeah, so yeast can actually create ethanol. What? Now, do you know anything about yeast? Do you know anything about it? Oh, you gotta be careful with that one. I'll come back to that in a sec. But it's certainly living. Agreed? Yeast is a living organism. So if you were going to grow yeast, what temperature would you want to put it at? What's normal? Oh, room temperature is 25. That's pretty chilly, that, for most organisms. If you want to keep it warm, things grow better when they're warm. So what's warm for yeast? What's the perfect temperature? 35. So we use 35. We don't go any higher. If you go higher than 35, what starts happening to the enzymes in the yeast? Oh, biology, eh? You denature the enzymes. Can I just point out, by the way, the biologist actually teach you what that actually involves. It's to do with the higher temperatures, the hydrogen bonding, which causes the tertiary and secondary folding, start to break at those temperatures, so the protein then unfolds out of its quaternary. You see, the biologists actually know anything, not real science. So, like, they just say, it's denatures, and the students go, how? And they go, I don't know, I'm not a real scientist. So, 35 is the perfect temperature for yeast. I've suddenly realized I'm still live on YouTube. 35 degrees is perfect for yeast, and we're going to make ethanol. Now, the question is, what do you feed them to do that? I like it. Okay, so Rue is going, I'm making sake. Yeah. So if you want to make sake, you're going to feed them rice. But can I just point out, it's a really difficult process, that actually, Rue. Yeah, yeast really don't like eating carbohydrates very much. What do they prefer? In fact, what do kids prefer to eat? Sugar. So what we put in is sugar. C6H12O6. Now, can I just point out, that's glucose. That's glucose. We use this in the equation because it's easier. Yeah, if you want to use sucrose, then it would be C12H22O11. Notice it's slightly off because you use water during the condensation reaction to join together. Your sugars, oh my goodness, what was this? Your monosaccharides. Yeah, I am a biologist, by the way. I'm not really. So, you take sugar and you feed this to the yeast. Now, here's the thing. Toby said oxygen. Now, this is actually going to be really careful with this, because you actually don't want to give them any. Yes, right. Can we put underneath the 35 brackets, we need to put absence of air. What this literally translates to is no air. Yeah, we don't want to give them oxygen. If you do give them oxygen, what are they going to turn the sugar into? They're just going to respirate, like we do. They just go through respiration, and they'll turn it into CO2 and water. And I don't know about you guys, but if I want a Friday night drink, if I get a glass with CO2 and water in it, I've just been given fizzy water, and that's going to upset me very much. Yeah? Otherwise known as sparkling water. Yeah? So we don't want to do that. So we need to give them no oxygen at all. And when you do that, they do something really wonderful, which is they turn it into ethanol. They turn it into alcohol. And they turn it into 2 of them, and they also do make CO2, by the way. They do make 2 carbon dioxides as well. So the whole process bubbles. Now, I wanted to talk to you about what this actually involves. Yeah, because this absence of air thing, really tricky. So here's how you do it. You take your container. You take your container. Yeah, you take your container, and what you're now going to do is you need to have water, obviously. Because we all know that organisms really don't like being dry. It needs to be in water. So we're going to put some water in here. Now, by the way, we're not going to use water, because if we're going to brew something, we want to make it a bit more tasty than just alcoholic water. Tonga. So what we're going to do, let's put some fruit juice in here. Yeah, let's put apple juice. Yeah. Let's put some apple juice in here. Right, the next thing is now apple juice has sugar in it. Would everyone agree? So that's awesome. It's like, yes, there's already sugar there. But the problem is, like, they're going to need a lot of sugar. So what we're going to need to do, add some more sugar to this. Yeah, we're going to now make this, we want to feed the yeast are living. We want to feed them, give them loads of sugar. So we're going to now add bulk loads of sugar. Yeah, let's just add a whole load of sugar. By the way, we will dissolve it. We will shake this up until it all vanishes. We're going to add bulk loads of sugar to this. Now what we're going to do is, we're now going to add the yeast. So we're now going to add a very small amount of yeast to this. Yeah. Now that yeast, yeah, the yeast will then start eating the sugar. I'll put on a little thing down here of, there's our yeast. Let's add our yeast in here. Yeah, we're going to keep them nice and warm, nice and toasty. Put them in a nice warm room somewhere. But now here's the real issue. We need to not let them have any air. But also, we need to be able to let the gases that they make out. Because here's the thing, everyone goes, oh, I need to get rid of all the air. So what I'm going to do is I'm going to seal it. You're about to blow up your kitchen. Because what's going to happen is the yeast are going to start eating the sugar, turning into alcohol and carbon dioxide. The carbon dioxide is going to build up inside the vessel, and the pressure will increase until it all blows up and you've got a reek mess. You have yeasty alcoholic fruit juice all over the floor, and well, that's just grim. So how do we now let the gases out, but not let anything back in? So this is called an air trap. Now, I'm actually going to draw you the one that they used during Roman days. So what they used to do, is really, really easy, is all you do is you have a funnel like this. And in that funnel, you put a ball, like that. Now, this is really clever, because the weight of the ball, they used to make the ball, by the way, out of marble, polished marble, so it's a nice seal. Yeah. So the weight of the ball makes it sit in this tapered funnel. Now, the yeast are going to create gas, and the pressure in the thing is going to increase. And eventually, what's the ball going to do? It's going to lift up. But here's the cool bit. As soon as it lifts up, the gas escapes, the pressure drops, and it falls back in again. Exactly, it just goes do, do. It lets the gas out. How simple is this? Yeah, it lets the gas out, but it doesn't let any gas back in. Oh. Say again. It's a pressure cooker is slightly different. We don't want this to build up lots of pressure. Pressure cookers are designed to let the gas out when it reaches a certain pressure. Pressure cookers terrify me, by the way. They are just terrifying. This is less than that. Like, you can make the ball different weights, by the way, depending on how often you want to let the gas out. Someone used to make them out of polished wood. Yeah, but as long as it was a nice fit, you had to make sure it was a good fit in the tube, because that way it doesn't let if there's a gap, the air's going to get in, and then it's going to turn into CO2 and water. But this is called an air trap. It's very simple. There is another way of doing this, by the way, which is to use in modern day terms, you use a water air trap, which uses a little U-bend, if you're interested. Yeah, it uses a little U-bend, a bit like this. And what you do is you pour water in the top of it, and the water sits here, like that. And what happens is when the pressure builds up, the water gets pushed up here until eventually the water gets to that level and the gas bubbles out and the water falls back in. Does exactly the same thing the ball's doing. It just uses water instead of, because it gives a better seal. But it's just to stop. But the thing is, you cannot have air in this system, because if you do, you ain't making any alcohol at all. You're just going to make CO2 and water. Now, this is a great method because, guys, you can do this at home. This is something that we've been doing for thousands of years. So what are the pros of this? What are the pros of this? Why is this good? Why do we love this so much? Go on, Ru. Safer. Oh, say again. Okay, that's fair enough. You're comparing it now to die. Oh, I'm going to take that one though. Low temps. Guys, this is low temperature. What that also means, you'll have to put these together. It means it's low energy. Guys, you don't have to heat this. You just have to put this in a room at room temperature. You don't have to, if you don't, by the way, if you don't have 35 degrees C, that's okay. It'll still work at 25. It'll just take you twice as long. Yeah. So this is low energy. The next thing is, what other good things about this are there? This is renewable. Because where's your sugar coming from? It's coming from plants. It's coming from apples. Just grow some more apples. This is renewable. This is renewable. Yeah. Low temperatures, so low energy. Yeah, it's renewable. Would everyone agree? It is also technically carbon neutral. Because the carbon dioxide that this is going to emit was removed from the atmosphere when the plants were grown. When plants grow, they do photosynthesis, and it takes CO2 out of the air. That's why we want to plant trees. Well, when you do this process, you just put the CO2 back. This is technically carbon neutral. Can I just point out, it's not, everyone should know that it's not really carbon neutral. And the reason why it's not really is because you've got to farm it. But it's still okay to say, technically, it's carbon neutral. Yeah? I'm going to add a little thing here, guys. Can you add this to your notes? Carbon neutral. Plants photosynthesize, removing CO2 from air, By the way, I'm gonna go the whole hog on this now. Guys, put your pens down for a minute, because they're going to take in carbon dioxide and water. This is photosynthesis, and it turns it into C6H12O6 plus oxygen gas, and then you balance it with all the sixes. I love that equation. It's boss, makes me so happy. It's the only reason why I like biology was that equation, because I was like, it's just got loads of sixes in it. It's amazing. It just works. So there's photosynthesis. Would everyone agree that every time the plant makes some sugar, it's taking out 6 carbon dioxides out of the air? So what we're now going to do is we're now going to take the sugar, now I'm going to take that C6H12, I'm going to ferment it and turn it into ethanol. Here's the proper structural formula rather than Edexcel's stupid one. And I'm going to release 2 carbon dioxides back into the atmosphere. So I removed 6 from the air during photosynthesis. I just put 2 back. Right, what's the major use of ethanol? I'm going to take those 2 ethanols and I'm going to burn them because it's a fuel. And what do I make? I make 4 CO2s plus a whole bunch of water. How many waters are we going to get? 12 in total, so 6, and we're done. So we put, in total, if you use ethanol as a fuel, you put back the same amount of CO2 as you took in through photosynthesis, except from transportation and farming. Yeah, but otherwise, it's much better than petrol. The fossil fuels are carbon dioxide that was locked away millions of years ago. Well, this is just something we can grow. This is called biofuels. Yeah, so you can grow your own petrol. Can be done. Can be done. You're going to need a big field, but can. Anyway, so it's carbon neutral. Okay, so we love fermentation. Anyone can do it, you know, but there are some cons here. We've got some pros, but there are also some cons here. So the question is, yeah? It's right. Okay, can I ask you please, guys, a chemistry rule, this is chemistry GCSE and A-level. Never, ever mention the word cost unless the question has the word economic in it. The reason being is it's actually way more expensive to brew alcohol than it is to do it via direct hydration. The reason the cons are going to explain why. Because What are the cons of this process? Now, guys, brewing is great for drinking. The problem is we don't want to drink alcohol, do we? We want to burn it. Guys, this is a fuel. Yeah, this is a fuel. So what are the cons of this process? Well, number one is the alcohol you're making is incredibly impure. You're only making about 12% alcohol. Most of it's just still water. You've also got dead yeast floating around in it. I don't know about you guys, but I don't really fancy shoving that in my car petrol tank. Yeah, it's just going to ruin my car. Yeah, so cons, number one, impure product. I'm not making pure ethanol. I'm making ethanol and a bit of CO2, and it's going to be loads of dead yeast, and it's going to be gross. This is not going to be this impure product, but of course we like this because it adds flavor. That's why we do this. Yeah. The next thing is, guys. Okay, here's unfortunately the one drawback that because I say this, you can do this at home. You can, but it's going to take you 2 weeks to get a drink. Yeah. Number two, it's slow. This is the problem. It's slow. It takes 2 weeks to do anything. Don't know about you guys, but it's just too slow for anybody who wants to drink on a Friday night. Yeah. So it's slow. The next thing is it is batch. What that means is once you've done a little bucket of this stuff, you've got to clean it out and start again. That's not good. If you want to make alcohol, you want to do it all the time. You just want it to be continuous. The next thing is it is high labor, which means it's usually quite expensive. Yeah, high labor. Impure product, slow, it is batch, and it is high labor. So don't get me wrong, there are some huge positives out of this, but there's also some drawbacks. And unfortunately, those drawbacks led to the chemists saying, I'm not happy. I want a faster method. So he went to direct hydration. Just to mention, by the way, guys, last little tack on for fermentation, yeast is a catalyst, just to let you know. Yeah, the yeast is a catalyst. Yeah, it's odd that, isn't it? A living catalyst. It's because the enzymes are doing all the work, and enzymes are catalysts. So it's just something to bear that in mind. 35, absence of air, catalyst which is yeast. Okay, now I've only got 6 minutes left to do direct hydration. I think what I'm going to do, I actually don't do it because I'm meant to finish fast. So I will end today's lesson at the end of fermentation. So we are halfway through. We're halfway through the making of, but we can definitely say that we know our uses. Yeah, the top two uses. It is a sanitizer, but number one is a fuel. Yeah, it's something just to add to your notes. Uses of ethanol. I will bring my lesson to a close there, guys. Hope you guys find it useful. If you want to then watch it back, obviously, guys, it's live on YouTube, so I'll see you guys soon.